Hey, what's going on, my ASVAB party people? Anderson here, your ASVAB coach. And in this video, I want to show you exactly how to tackle these rate word problems. Because look, I understand that rate word problems, when it comes to distance, rate, and time, it can be tough. It can absolutely be tough. And so in this video, as a courtesy to y'all, I want to show you the right way and the different scenarios that you can deal with. That way, you can be more confident, know what you're doing next time you tackle these problems. And again, Ace the ASVAB. So with that said, let's go ahead and dive on in. So here again, we're going to look at four main examples. Plugging in to solve, finding missing pieces so that you can plug and solve, having a situation where you have one object and two scenarios, and having two objects with the same scenario. So these are the four main types of problems that we're going to be going through in this video today. So go ahead, put your hard hat on, we're going to get this done. But before we do, remember to write this down. This is the main formula that we're going to be dealing with. It is distance equals rate times time. We're going to be using that all day in this video. So with that said, let's go ahead and take a look at the first example here, where again, it's just kind of like a plug and solve kind of situation. So take a look here. The problem reads, a car travels at an average speed of 50 miles per hour for 6 hours. How far did the car travel? So pretty much again, start with the question here. Let's understand what it is that we're really trying to figure out first. It says, hey, look, how far did the car travel? Okay, so first and foremost, this is what we need to do in word problems. Whenever we look at the question, we got to ask ourselves, what is it that they're asking us to figure out? And because this is a rate word problem, I hope that you can tell that when we see the phrase, how far, that means distance. That means distance. We are looking for distance all day long, all right? And so again, how far means distance, and we want to know how far the car traveled. So far, so good? Cool. So next what we're going to do, and let me just make sure to write the formula out so that we really see what's going on. Distance equals rate times time. All right? And so let's go ahead and see what we are given. We see here that the car travels at an average speed of 50 miles per hour. Right there. So what is that 50 going to be? What is that 50? Let me use red here. What is that 50 going to be? Well, that's going to be your rate. And the reason that that's a rate, there's a few different ways we can tell. One way is because they say speed, pace, rate, right? So we can tell that way. Another way you can tell is that really key word here, per. Miles per hour. That connects your distance, miles, and time, hours. Distance per hours, or distance per time, essentially. And so what we have here is a rate, because again, miles per hour is a speed, a pace. So again, the rate that we have equals 50 miles per hour. Remember that we're looking for distance. So keep in mind, we're looking for distance. We have the rate. Do we have time now? Because if we have time, we can plug it in right there, plug it in with the rate, and find our distance. And truth be told, we do have it. It's right here. In green, 6 hours. That's going to be the time that we're working with. Let me grab here these colors. Time equals 6 hours. Right there. And so we can solve for the distance. We can solve for what we're looking for. But I hope you can start seeing that it's not just about, oh, grab the numbers, mash them up, hope for the best. No, what we need to do here is understand what we're trying to find, understand what we have, and move forward from there. And so with that said, how do we get the answer? Well, we're looking for distance. It's going to be equal to the rate multiplied by time. And so all we're going to do is plug everything in. 6 hours for time, 50 miles per hour for the rate. What is 50 times 6? Well, 50 times 6 is 300. So distance equals 300 miles. Booyah. And that's the first question there. And so I hope I'm not going too fast, because you can always pause and rewind. But there it is. That's how we would get 300 miles for that first one. Here, again, we're just plugging and solving here in this scenario. Because again, they just tell you, hey, we are looking for the distance, the rate, or the time. We're looking for one of these three. And we're going to give you the other two pieces, plug them in the right places, and solve. So let me just say this one thing before I move on. Is it always going to be solving for distance? No. Sometimes we're going to be solving for the rate. Sometimes we'll be solving for the time. It just depends. But either way, you have to understand what pieces you're plugging in where and then solve. So that means that you're not always going to be multiplying. Sometimes maybe you'll be dividing to get the r by itself or the t by itself. So again, I hope that makes sense, because now we're going to look at scenario number 2. Scenario number 2 here, we're looking at, hey look, we have to reason a little bit because we have to find some missing information so that we can solve this. So here's the thing. I'm not going to read the whole question. When I solve word problems, the first thing I do is actually going straight to the problem, or the question sentence itself. I am not going to go ahead and read through all of the information because I don't know what it means yet. I don't know why I'm reading it. I don't know what it's for. I'm going to read the question first so it can direct me as to, hey, what information are we trying to find and what's going to be important for us to look for when we go back to the problem. Simple as that. So let me highlight the question statement. That way we're good to go. Right here, how many miles or how many total miles did the family drive while on the road trip? So look at that. How many total miles? All right, so this is what makes arithmetic reasoning difficult. Yeah, we're going to be applying distance equals rate times time in this problem, but at the same time, we have to use our intuition here. We have to be intuitive about this and use our common sense to connect the right pieces in the right way. It's not going to be as simple as D equals RT. It is not. We'll be using it, yeah, but there's a much bigger scheme to this problem. So let me show you what we mean here. So we want to know the total miles. So total miles. So what does that mean? What is miles? Miles is a distance. It's not a rate. It's not miles per hour, right? It's not a time. It's not hours. It's just total miles. So we're looking for the total distance. And so this is why it's so important to read the information and understand it. Watch this. Let's read along. A family went on a road trip, traveling to 4 destinations and then returned on the same route. I'm going to highlight that right there for us. And then returned on the same route. Let's just talk about what that means for a second, just for a quick moment. Think about it. If you're talking about going somewhere and then returning home and you want to find the total distance, well, pretty much what that means is if you know how far you went, double it to get you back, right? So if I go 10 miles to the grocery store, hopefully that's not that far for you, but if I'm going 10 miles to the grocery store, I got to go ahead and then add 10 again to come back. So 20 total miles. So in green right here, I got to be specific. Trip there times 2. Because again, returned on the same route. We have to multiply the distance by 2. All right? Multiply the distance by 2. So we're going to find the trip there, the distance there, and then multiply it by 2. So you see how it's not all like puppies and sunshine, plug and play? No, we have to find it using reasoning here. We have to reason with this. So let's go ahead and take a look here. We have these 4 destinations. I'm not sure how important that is right now, but nonetheless, let's go ahead and take a look at what we have. So they drove 120 miles to their first destination. Okay, that's good. That's actually pretty good here. Okay. So destination 1, 120 miles. Because again, we have 4 destinations. Okay, so first trip, 120. Okay. Next, what do we have? Let's use pink here. 60 miles per hour for 2.5 hours to the second destination. Okay, so here's the thing. Did they give us a flat out distance? No, they really didn't. They absolutely did not give us a flat out distance. But what we can do with this information is we can see that they give us, I'm going to go ahead and use a highlighter as well, a rate, 60 miles per hour, and a time, 2.5 hours. What was the formula again? Distance equals rate times time, right? Rate times time. Here's my rate. Here's my time. I can multiply those together to find the distance for that second destination. I hope we see that. And if you don't, rewind again. But for that second destination, we see that we're going 60 miles per hour for 2.5 hours. And what that means is to find the distance, we'll get 60, the rate, times 2.5 hours, which is time. 60 multiplied by 2.5 is 150. So, boom, 150 miles. That is the distance for that second destination. So here's the first Here's the second. And we're going to continue moving forward to find the third and the fourth. Once we find all of them, add them together. But don't forget, remember we said that we have to multiply it by 2. So that way we can get the return trip as well. Because they said, again, total miles that they drove on the road trip. There and back. Return on the same route. I got to make sure I'm saying this and being repetitive because, again, the context, it looks like a lot, but it's so important because, again, you can't get the right answer without it. And yeah, if you're asking, hey, can I get this done in under a minute on the ASVAB? Yes. With practice, you'll be able to look at something like this and be like, oh, okay, rate, time, find that distance, do this. Okay, cool, add them up. Done. And you can get that within a minute. You absolutely can, maybe a minute and a half, 2 minutes. But again, it's an average amount of time on the ASVAB for 1 minute. So you can do this. Here we go. Destination number 3. I'm using blue now. Let's get it done, gang. So here we go. 45 miles per hour for 2 hours for the third destination. Okay. Same deal, right? 45 miles per hour for 2 hours. What's that going to be? Distance equals 45 times 2. That is 90 miles. So that's 90 miles for that third destination. And then lastly, they kind of help us out here. They make it a little easy on us. They say another 50 miles to the last destination before returning home. So what that means is for that fourth destination, right there, just 50 miles. And so with that, boom, let's go ahead and highlight everything here. 90 miles for that third trip, 50 miles for that fourth destination. So all we're going to do now, add everything up and then do what again? Multiply it by 2. Again, you got to keep in mind that context there. And this is all about learning how to reason with mathematics here. So we're going to have 120 plus 150 plus 90 plus 50. You can use mental math to add this all up, or you can go ahead and just solve it as I put it out here. Either way. But all the zeros together is 0. You can add them all up here. 2 plus 5 plus 9 plus 5. What's that going to give us? 1621. And that's be 410. Another way you could do it with mental math, you could say, hey, 120, I know that looks like a 4, that shouldn't, there we go. We can say 120 plus 150, 270. 270 plus 90, 360, plus 50, 410. That's just another way you can do it. Either way, again, there's just a bunch of different ways. It's up to you. Really, it's up to you. But there we go. We have 420 miles there. Okay? 420 miles there. And so how far are we coming back? 410 miles back. 410 miles back. And so what are we going to do? We're going to add these together. Double it. You know, we can say 410 times 2. You can also say 410 plus 410. But regardless, the answer here would be 820 total miles. And that would be D in this case. So I hope you're starting to see that, look, it's not all puppies and sunshine. We have to understand how to apply these formulas, not just knowing that, oh, I hope that the formula works. No, the formulas are there as a tool, not a solution. Remember that. Formulas are tools, not solutions. So let's go ahead and take a look at this third one here. This is another one, another type of problem that you may or may not see on your test. And we got to make sure that you're prepared for it and understand how to tackle this type of problem. So next, again, we always say, read the question first. This is a scenario where we have one object going through 2 separate scenarios. So I'm going to explain what that means in a moment here. But here we go. First things first is read the question. How long did the trip there take? Trip there if the return trip took 3 hours. So how long did something take? What are we looking for? Again, don't worry about the other information. Don't worry about all that right there. Don't worry about all that yet. We're asking ourselves, first and foremost, what are we looking for? How long did it take? How long did it take? That's time. How long does something take? 3 hours, 2 hours, I don't know. But that's going to be time. So we're looking for time. And the thing is, they specified, they said trip there. The trip there. So let's go ahead and make sure we have that nice and clear here. Trip there. Because you see here it says return trip. I'm going to use red for that. Return trip took 3 hours. So I'm going to write this here on the side as other information. We see that we have the return, the time equals 3 hours. So far, so good. All I did was point out that I want to find the time, how long it's going to take. And second, I want to make sure that I wrote down the information in terms of the return trip and the trip there. I'm just separating them really quick because we're going to go ahead and fill in the information in their buckets, and then we're going to see what we're going to do to figure this out. But let's read through the information now. Henry made a trip to his friend's house and back, taking the same route. I got to go ahead and point out that this is a very important piece of information. Even though it doesn't use numbers, that's still very important. Taking the same route. What does that mean for us? What that means, and I'll go ahead and zoom in here. What that means is that the distance there equals the distance back. The distance there equals the distance back. They are the same. Think about it. If you take the same route going somewhere and then coming back, that really means, hey, they're the same distance. So if I'm going ahead and trying to find the distance here, because I'm going to need it to solve, right? Well, these distances are the same. Whatever they are, they're going to be the same. And that's going to be very, very useful for us in just a few moments. So keep reading along and let's keep collecting the information. Next, on the way there, okay, let's go ahead and highlight that for blue. Trip there, on the way there, he biked 15 miles per hour. Okay, biked 15 miles per hour. So 15 miles per hour, what is that? That is a rate. Miles per hour. That is a rate. Equals 15 miles per hour. And then we see here in red, on the way back, he biked 20 miles per hour. So the rate for the return trip, again, per miles per hour. The rate for the return trip, 20 miles per hour. And that's all the information we have. And that's it. And what are we trying to find again? We're trying to find how long the trip there took. Again, right here, first thing we wrote, we want the time it took to get there. Well, here's the thing. We have time here that we want. We have a rate that's given to us, but we don't have the distance. How the heck are we supposed to solve this if we don't have distance? If we're looking for time, like that doesn't make sense, right? Here's the thing. Remember, the distance there is equal to the distance back. Let's look over here. Focus your attention right here. Can we find the distance right now? Yes, because remember, don't forget, guys, don't forget. Distance equals rate times time. Guess what? Time 3 hours, right there. 20 miles per hour is the rate, right there. My distance equals my rate times time. What's 20 times 3, gang? 60. 60 miles is the distance to his friend's house. And guess what? If it's 60 miles there and he took the same route, that's 60 miles back. I hope that makes sense. Pause the video, rewind it if you need to, but that's all I'm trying to portray here. Again, if we say that we're taking the same route there and back, those two distances are the same. It's one person, Henry, two different scenarios, 2 trips. One trip there, one trip back, and we were able to make the connection that, yeah, we got the same distance there and back. So now we can use this and solve and actually figure this thing out. So we're looking for the time. We're looking for t. We have the rate. We have the distance. Remember, distance equals rate times time. So what I'm going to do is remember, distance is right here, 60 miles. My rate that I have right here, 15 miles per hour. And so I'm going to plug that in now too. And then lastly, I'm looking for the time, so I'll just write t for time. I'll just write t for time right there. So what are we going to do? What are we going to do? Well, solve the equation. How do we solve an equation again? Remember, look at the variable, Look at the variable. If there's anything attached to it, do the opposite. 15 times time, okay, divide by 15. On both sides, cancels out, gives me t equals 60 divided by 15, and that is 4 hours. Boom, boom. And this makes sense too. Like, take a moment to really think about this. If you're going 20 miles per hour and that takes you 3 hours, think about it. If I'm going slower now, 15 miles per hour, so from 20 to 15, should it take less time or more time? It should take more time. Before it took you 3 hours going fast, going slower, it should take you more time, 4 hours. So that should make sense. A is definitely not an answer because that wouldn't make sense if you're going slower, but you're actually faster. Right? That doesn't make sense. So I hope that you can see where I'm coming with this and where we're going in terms of looking at these scenarios in the right way. Because now we're going to look at the fourth scenario. This is the last one here, and this is arguably one of the more difficult ones. So let's go ahead and take care of business here. First things first. First things first. We're going to go ahead and read the question. How long will it take for the cars to be 120 miles apart? So guess what? Look at this. Notice how they're saying, how long will it take? So we're looking for time. We're looking for time. Yeah. I'm going to do that kind of face because it's math, right? But let's go ahead and be more serious here. Notice how they say, how long will it take for the cars? How many cars? More than one. We have two objects here under the same situation, the same scenario. So watch how we're going to handle this now. Watch how we're going to handle this. We're looking for time. So it's one scenario, so you're only going to be needing one distance, rate, time equation. Okay? So with that said, boom, we're looking for time. Do we have a rate? Do we have a distance? Because if we have these things, we can plug it in and solve. So rate, do we have anything here? Two cars starting in the same place begin driving without stopping. Car A travels 25 miles per hour, while car B travels 15 miles per hour, and they're going in the opposite direction. So right there, first and foremost, car A, 25 miles per hour. Is that a rate? Absolutely. Car A, 25 miles per hour. What about car B? Car B, I'll use the green highlight here, travels at 15 miles per hour. All right, and then let's highlight this very key piece of information here. I used red and green, so I'll use blue to mark that they are going in the opposite directions. So opposite directions. Here's the rule. Directions. So here's the rule. Write this down if you've never seen this before. The rule is same direction, we will subtract the rates. Subtract the rates. If it's opposite directions, you add the rates. Okay, write that down if you've never seen that before. But here's why. Think about it like this. If we are looking at, let's go ahead and say the two cars starting in the same place, and I'm looking at red with car A going this way, and then car B, I'm gonna use blue or green, excuse me, to make sure I'm using the right color. Car B going that way. Guess what? If we're trying to find out how far apart they are, excuse me there, that's A. If we're trying to find out how far apart they are, think about it like this. Well, if I'm going this way for a bit, and then green is going that way for a bit, guess how you're going to find the total distance? You have to add these together. You have to add them together. And so if they're going in opposite directions, this car is going this far, this car is going this far, and to find the total distance, you have to add this and that. If they're going in the same direction, think about it. If we're going in the same direction, this car goes this far, this car goes this far, the distance between them, you have to take how far this car went, subtract how far this car went, so you can get how much space is in between them. And so I hope you see that. Replay that part of the video if you need to. Opposite directions, you add the rates to find the total there. If it's the same direction, you subtract the rates to see what's in between them, to take away what they've both already done, what they both covered, to find what is in between. And so in this scenario, because we're going in opposite directions, we will do what again? Add the rates. Add the rates. And so with that, we'll add these rates. And so the true rate, let me take this and move it down a little bit. The true rate will be 25 plus 15, which is 40 miles per hour. That is the true rate that we're dealing with. That is the true rate that we're dealing with. And again, the only reason that we knew that we had to add these rates to begin with is because we're trying to figure out how long it's going to take for the cars together to be 120 miles apart. So we know that it's one scenario that we're dealing with, two different objects, two cars here. And so there we are. What is the time? Well, we're looking for that. What is the distance? Right there, 120. 120 right there. So my distance is 120. My rate is 140. I'm looking for time. Let's go ahead and fill it in. D equals RT. Our distance right here is 120. My rate is 40. My time is T. All I have to do now, take a look here, divide both sides by 40, and we are golden. T equals 3. 3 what? It's T for time. 3 hours. Booyah, we're good. And we can say confidently that we've got the right answer in A. And so with that said, gang, again, I know this isn't easy. I know it's not. There are 4 different scenarios that we can deal with in terms of rate word problems, but with more practice, you'll be able to tell which one you're dealing with, whether it's just, hey, plugging and playing, or finding out the pieces that we need to gather to find the entirety of it, or if it's one person going through 2 similar scenarios, or 2 objects in the same scenario. You just have to continue practicing and reading, and you will get faster at this. I promise you will. But we can't give up too easily. We have to continue trying, because to hit a breakthrough, well, you can't break a wall or break through anything if you stop trying, right? So keep putting in that time, keep putting in that effort. I've got your back 100% of the way. And so with that said, my ASVAB party people, I'm Anderson, your ASVAB coach. Love y'all. You have a good one. See you in the next video.